Hello and welcome to another video. In this video we're going to be working on ugly number 2. And in this one you have an ugly number that's a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return the nth ugly number. So here the 10th ugly number is 12. So that's what you return. And then for 1, 1 is the first ugly number. So 1 doesn't have prime factors, so this works. And all of these are only divisible by 2, 3, and 5. So let's talk about a couple of ways we could do this. The worst way would be just go through every single number until you hit enough numbers. So you check like, is 1 an ugly number? Is 2 an ugly number? Is 3 an ugly number? Is 4 an ugly number? And so on. Now the problem with that is I just tried this for this constraint. So I think if this constraint is this is like 10 to the 9th or something. So first of all, you'd have to look through 10 to the 9th numbers, and also to figure out if a number only has 2, 3s, and 5s as factors. I think to figure out factors of a number takes like square root of the number or something. So that was going to be like, you know, square root 10 to the 9th times 10 to the 9th, something like that. So that is not ideal. So ideally what we want to do is instead of going through numbers and checking, ideally you just want to build all the ugly numbers in a sequence like this somehow. And then just when we get to the right one, then we're done. So ideally we want to like build this one, then build this one, then build this one. And so there's two ways of doing that. One I think is pretty easy, and one is a little bit difficult and hard to understand. So let's talk about the easy one first. So the easy one is we just start out with a number 1. And we can just have a heap. So let's say we have a heap. Let's just draw something. So we start out with a number 1. Maybe let's go through this example. Yeah. So start out with the number 1, and all we're going to do is we're just going to maintain a heap and a visited set, and then we're going to take the smallest number that we have and then try to multiply it by 2, 3, and 5. And if we don't already have that in here, then we will add it in. And we will do that until we pop out 10 numbers, and then that's going to be the 10th smallest. So let's kind of walk through that solution. So like we have visited set right now, and we visited 1. Then we're going to pop the 1, and we're going to make 2, 3, and 5. We haven't visited any of those, so we'll put in 2, 3, 5. And we'll add those to the visited set. And so now we popped 1 number so far, so let's keep track of that as well. So we popped 1 number. Then we popped the 2. So from the 2, we can make 4, 6, and 10. So let's add those as well. And now we visited 2 numbers, and we have 1, 2, 3, 5, 4, 6, 10. Then from the 3, we can make 6, 9, and 15. We already have a 6, so we can just make 9 and 15. So this will be our heap. And then we popped 3 numbers, and so we need to add 9 and 15. And I'll do a couple more. I don't think I need to do the whole thing, but you kind of get the idea. You're just popping numbers 1 at a time. So the smallest number is now 4. And then you're basically just building the 3 you can build from it. And once you pop the 10th, because you have a min heap, or you know the nth number, that's going to be your answer. So from the 4th, you can build 8 or 12 or 20. And none of those are in there, so you would put in 8, 12, and 20. So that's kind of the idea. So we'd have 8, 12, and 20. And let's say we were looking for like the 5th smallest number. So we popped 4 numbers so far. We add 8, 12, and 20 in here. And then finally, this is going to be the 5th smallest number that we popped. So that's going to be our answer. And that's basically how you do it. And that's pretty straightforward. So for every number, you just have visited set to make sure you're not like redoing stuff. And that's going to be like an n log n solution. We're doing something efficiently. The problem is we're still using a heap, and we're making a lot of numbers that we already have, right? Like we make a 10 here that we already have. We make a 15 that we already have, and so on. So that's like I would say the medium solution to that. Now let's talk about the difficult solution. So the difficult solution is doing kind of the same thing, except in a more efficient way. And so basically, if you think about it, the 3 things we can do is we can multiply a number number by either 2, 3, or 5. And we're going to try to make the smallest number possible at every single stage that we don't currently have. So let's walk through that solution. And we're going to need a couple things here. I don't know why that's there. Okay. So we're going to start out with the 1. And then basically the idea is we want to multiply the smallest number we have by the 2, 3, and 5, but we don't want duplicates. So we're going to have a pointer here for this 2, 3, and 5 of like what numbers have we multiplied already. And if we multiplied it already, then we'll move up the pointer. So in the beginning, let's make these. So you're basically going to have 3 pointers. You're going to have a pointer for what number you're going to multiply by 2, what number you're going to multiply by 3, and what number you're going to multiply by 5. Let's maybe color code that as well to make it easier. So this is 2, 3, and 5. And so the idea is we haven't multiplied anything. So this is our choices. This is our choices of the next number to make. So we can either multiply 1 by 2, 3, or 5. Okay, so the smallest number we can make here is going to be the 2 when we multiply the 1 by the 2. So we'll make a 2. And then we're going to take this, let's straighten these out a little bit. And we're going to take this 2 and move it up because we've done 1 by 2 already. So now we want to move this to the next smallest number we can multiply by 2 that we haven't yet, which is this. Then the next number we can make is either a 1 times 3, a 1 times 5, or a 2 times 2. So 3 is the best. So we're going to take this 3 pointer and move it to the next smallest number we can use. So now we can make a 4, a 6, or a 5. So 4 will be best. And we'll move the 2 to the next number we can make. Now we can make a 5, a 6, or a 6. And this is going to be an edge case. So, or not an edge case, but something tricky here. So the smallest is a 5. Now next, we can make a 10, a 6, or a 6. So notice that 2 by 3 is 6 and 3 by 2 is 6. And you don't want to, like, let's say I just pick the 3 and then I just move the 3 up. The problem is I don't want to do this. I don't want to do 3 by 2 because I already have this. So what we're going to do if there's a tie and they make the same number, like in this case, you can pick either one of them and make that number. So we'll make the 6. And then we're going to check both of the pointers and check, is this 2 by 3 equal to 6, the number we just made? If it is, we'll move it up, which it is. And is 3 by 2 equal to 6, which it is, and we'll move that up as well. So once we get our value, we're going to check all our pointers and make sure they don't equal that value again. So you don't have like the same number. Okay, so now we can either make a 10 or a 9 or an 8. And so 8 is best. Then we move it up. And then once again, we're going to check, and there's no duplicate here. And then here we can make a 9, so that's the best. And then move that up. And then we can make a 10 or a 10, which once again, both of them make a 10, doesn't matter, or a 12. So we're going to make a 10, but because both of them are equal to it, right, 2 times 5 and 5 times 2, we're going to move them both up. And then the last one, we can either make 15, or we can make 12, or we can make 12. So we'll make 12, and we'll move both of them up. Hopefully that makes sense. So you use these. The idea is basically like you want to make the smallest number possible multiplied by a 2, 3, or 5. And then you just keep track of like what number did I already multiply by 2, 3, or 5. And if I already done that, let me just do the next one that I have available. And so it's pretty clever and pretty tricky. I'd say the heap one is a lot more straightforward, but this is the one we're going to code up. Hopefully it makes sense. And if you were to ask like, how do I think of this? The idea is you want to think like, okay, I want to like figure out how to make these by adding the next number that goes in here. And the next number that goes in here is the smallest number that I haven't done something to with these choices. So hopefully that makes sense. But definitely, like, if you were asked, like, oh, I can't come up with this, okay, the heap is pretty straightforward, and I would just do that. But the brute force is bad. So I'd say, like, brute force bad, heap doable, this one kind of tricky, and if you didn't come up with it, totally fine. Okay. So we need to have an index of where we are for these three things. And then we need to have like our total array. So we can say like int array ugly nums or something equals, yeah. And this is length n. and ugly nums 0 will be a 1. And then we need these locations, right? So we need the 2's location, the 3's, and the 4 and the 5. So we'll say like and 2's 0, and 3's 0, and 5's 0. Now we're going to loop through our numbers, and we're going to check for the smallest one of these, and then we're going to move them up if needed. So okay, and so our next number to put in, so ugly nums I will equal the minimum of ugly nums at 2's or ugly nums 3's or 5's. One of those. Now, if any one of those is equal to these locations, then we have to move them up. So if ugly nums I equals, just copy this, ugly nums 2's, then we have to move 2's up. And same thing for 3's and 5's. So 3's and 5's. And finally, at the very end, we can just return ugly nums and -1. Okay, let's see if we screwed anything up. This should be 1. Yep. N equals 10, we got a 1. Oh, right. So this needs to be ugly nums 2's. So this is the location of like the number you're going to multiply by a 2, but we actually have to multiply it by a 2. And we actually multiply by 3, multiply by a 5, and same thing here, 2, 3, 5, right? Because this is the location of the number that you're going to multiply by these. So let's put in the test case, and there we go. Okay. Okay. So this is linear time, linear space. Definitely kind of tricky, but these kind of problems do exist where you're trying to build every number possible from some combination of like, I can do these things and like, how do I build these numbers in a sequential way? And this is basically how you keep a pointer for every single like choice you can make where the smallest number is, and it's always going to be the next one is always going to be the smallest one of those. So if you're building like a multiplication table or some other stuff like this, where you can maybe add different numbers or something like that, you can kind of do the same exact thing. Yeah, and I think that's going to be it for this one. So hopefully it was helpful. If it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.